Okay, I think let me start with the agenda of today. In sections, if we have 2 hours, what I will try to do is I will try to put an agenda at the board so that we'll follow at the end what we are doing. Okay. Now the agenda that we're going to have today will be as follows. We'll be talking about processes that we started last week, and we did some work yesterday. And first of all, what we're going to do is we're going to spend some time on the rice cooking example. Now, I know that this is a simple example, but I think it's a useful example with respect to keeping certain details in mind. Okay, once you see a video that's in a visual way, it's harder to forget about that. So we're going to capitalize on that idea and make some remarks. Then we're going to start talking about airport operations. And what I will do with the airport operations is basically I will try to introduce some details. And after that, what we're going to do is we're going to work together on some details, and we're going to start figuring out a certain process that I already asked yesterday. And finally, we're going to work on some improvement ideas that of course, is not going to be available at the clips that we have seen yesterday, but we're going to discuss those and we'll see whether we can do some improvements. Now, today, I am planning to emphasize the following keywords. These are important words that you should remember. You should always remember that I am not going to ask a definition of these words. That doesn't make sense, but these are the words that I'm expecting you to understand in some detail, and it will be important not only for this course, but for your general education in industrial engineering. So one of them is performance measure. One of them is the word improvement. And another one is the idea of complex situations. And then the fourth one is mathematical representation. Now, what I will do is in the rice cooking example, I'm going to create a mathematical representation example just to clarify the picture with respect to what I mean by mathematical representation. Okay, so this is the agenda of today. So I'm going to keep this here. Well, I will put it down at some point in time, but I will always remind you of what we are doing here with respect to today's work. Okay, any questions on this? Okay, let me start a little bit by giving a little bit more detail about the rice cooking example. Now, what we have seen is that's a simple example, of course. We have seen that rice cooking can be done in various different ways. So it means that it has alternatives. Having alternatives is actually one situation that fits complexity. If you have a lot of alternatives, okay, selecting one of them is not that simple. If you don't have alternatives at all, then of course there is no possibility of making a different decision. Okay? It's either you're going to do it or you're not going to do it. That's another type of decision, but it's with respect to doing it or not doing it. Whereas if you decide on preparing a rice dish, then you have various different alternatives in front of you. Okay? So this is one aspect of a complex situation. Now, what is the other aspect? The other aspect, it should have a motivation, an economic motivation. Okay? And we described that yesterday. Of course, when you are preparing it at home, you are not going to have an economic motivation, which makes a lot of sense. But if you are a caterer or if you are doing it as a business, then it becomes seriously important. Okay, so this is actually, today let me start with this rice cooking example. Do you have any questions on the process or on the discussion that we had yesterday? Anything which is not clear? Because I'm going to base most of the things that I'm doing here on what we had yesterday. Okay, no questions. Okay, now in this example, now what I'm going to assume is the following. Let us say that I am now simplifying the picture. So simplify the rice cooking example, because it has a lot of intricacies, actually. If you remember, you can have a frying session, you can have a number of different ways of preparing it. So there is a lot of things that you have to decide. But let's make life a little bit simple. Let me assume that we have two things which are important. And here on this axis, let me place intensity of heat. Okay? So this is one thing that I'm going to do. And here on the other axis, let me place what I will call cooking time. Now, there are many choices, of course. Yeah, given a certain intensity of heat, you still have a choice in between different cooking times. Okay? Now, I'm making this simple. So I'm making some assumptions. Now, why am I making those assumptions? I'm making those assumptions to simplify the actual world, because I cannot take the actual world as is and solve all the problems in every detail. Now, in this problem, in this setting, what I'm making is I am assuming a single type of rice. Okay? So there is a single rice that I have in mind. Let's call it a basmati rice. But you have millions of different basmati rices. So this is a particular type of rice. Now, what else should I assume? Well, I assume that let us say that my equipment is fixed. So a certain pan and a certain kitchen. Because probably what I'm going to show you is going to change if I move from this lousy pan to a more sophisticated pan. Okay? So you can see that now these are assumptions, but at the same time, these are the possibilities that I limit in order to be able to make some measurement and to make, at the end, eventually come up with a decision. Okay? So the assumptions are not always bad. You have to control certain things. If you don't control anything, then decision is going to be very difficult. Okay? So you have to control certain things to lower your list of alternatives, to have a reasonable list of alternatives. Okay, so I have a certain type of a rice. My pan is the lousy pan that I have in the second clip. Okay, and the kitchen that I have is the small kitchen with a certain stove. Utensils are already given. Okay. Now, what I have is I have intensity of heat and cooking time. Now, of course, you can see that if I increase the intensity of heat, cooking time is going to go down. But there is one thing that you should remember. There is no particular exact time for a given intensity of heat. You can have a rice which is more cooked or less cooked, but still it will be a good quality rice. Okay? So the picture that probably I'm going to get if I do enough number of experiments will be something like this, where this area is the area that I will call admissible alternatives with respect to quality. So I am using the word quality in a very general term. So this is simply saying that if the quality that I want to have is at a certain level, this is the set of admissible alternatives. Admissible means that alternatives that I can accept with respect to the end quality that I have. You are not going to see this anywhere else but on the video only. So I can see that some of you are taking notes, but some of you are just looking at here. So you may want to, instead of listening to the video of the course over and over again, you may want to take some notes. There won't be any other handouts regarding to this. Okay, so you can see that this is admissible. Admissible means that the set of alternatives that I will accept because of my quality limitations. Now you can see the logic of this. If I have more intensity, probably I'm going to burn everything. Okay? If I have less intensity, probably nothing is going to be cooked. It will have an awful taste. On the other hand, here the alternatives for a given intensity of heat increases because it means that you can have different types of rice, well-cooked, well-cooked, or you can have degrees of cooking, and each of it will have a good taste and is acceptable. Okay? So this is basically one thing that relates intensity of heat and cooking time. Now, who is going to give us this information? Are we going to get this information as industrial engineers? Or who is going to supply us this information? Any ideas? Now, in practice, of course, you have different engineering fields that deals with these type of details. For example, food engineering. Okay? Now, if you can collaborate with a food engineer, then you may be able to get this type of an information. Now, of course, in order to be able to hire a food engineer, you have to make sure that you have a reasonable demand for the rice that you cook. If you are cooking it for your friends, that won't be sufficient, of course. Okay? So always keep that in mind, because we are now extending it to a business, and we are now hiring professionals, engineers, and so on and so forth. So things are getting out of control. But that's the reason why we always say that industrial engineers are only needed if there is a complex situation and if there is a certain economic motive. Okay? Of course, you can do it in an amateur way in order to basically satisfy whether you understand the industrial engineering approach or not. This is what we are doing, actually. Okay? Now, so this is something that you can get. Well, is it easy to get this? Probably not. So what we usually do is we usually set up some experiments with the professionals who are knowledgeable about these type of issues, set up some experiments and try to get this type of an information. Now, how are we going to use this information will come later. But this is what we do, actually. Now, how are we going to set up experiments? Now, the simplest experiment that you can think is hire a chef, okay, and set up a certain kitchen with a certain pan, with a certain type of rice, okay? Let the chef cook a number of times and have Vedat Milor coming there. Vedat Milor is the guy who tastes all the foods in a vicious way, okay? And he's, well, I know him from 1980s, early 80s. He has a PhD in economics, and he is at the same time an international lawyer. Okay, but he's not doing any of those. He's just doing food tasting. Okay, which is very good, actually. So basically, you're going to hire Vedat Milor. Okay, and Vedat Milor is going to tell you the admissible test set. Probably his admissible set is going to be very small. Okay, but basically, this is how you are going to obtain this information. But is that going to reflect all the possible situations for this given rice, given pan, given kitchen? Unfortunately, no. It's a sample. Sample, it's only part of the reality that we observe. But using that sample, we can obtain some inferences. Okay, now, something that you're going to learn in later years is in the course statistics, probability. You're going to learn how to take those samples, how to make a sensible, acceptable result out of this observation. Okay, so this is something that you're going to learn. So there is a technical background related to that, and you're going to learn in the second year. Okay, but this is what we do. So we sat down with another engineer, a person who is very knowledgeable about the quality. Okay, of course, in some cases it will be easier because we're going to have a ruler. With the ruler, we're going to make a measurement and say it is acceptable or not. But when it comes to taste, it's more difficult. Okay? So this is actually one information that we can get. So for a given rice, for a certain pan, for a certain kitchen. Any questions on this? Now, this is a set which is defined with respect to cooking time and intensity of heat. Can I write it in a certain functional form? Can I write it? Of course I can. In other words, there might be some, in reality what I will do is I will make some estimations. So these are the observations that I actually have from the experiments. And this is the way that I prepare the set. So from these points, I can come up with a definition of a certain set. Okay? And everything is a mathematical representation. Now, how am I going to use this? Well, that's the next step. Any questions on this? Is it clear? So this is one experiment that I run. Yes, go ahead.
I don't understand that why we say as an area. Why don't we say as a straight line?
Okay, because basically, I know that. This is coming from the physics of the problem. Okay? This is basic. You are cooking rice. You have a certain intensity. You know that if you cook it 3 minutes or 3.5 minutes, or in between 3 and 3.5 minutes, it will be good. But it will have a different taste. But it will always be good. So we're talking about this possible line. Cooking time is different, but the intensity is exactly the same. Of course, you will have situations where everything is going to be a straight line. But you're right. Now, but what this set is at this point, this set is called feasible region. Feasible region, the region that I can accept. Now, the region outside this, I'm not going to accept because the quality is going to be very bad. So this is my acceptable region. This is called feasible region. We're going to see this in some other methods that we are going to learn this semester. Of course, you're going to learn this word in later courses as well. Okay, so this is the feasible region. Now, what is the role of industrial engineer? Industrial engineer, number one, should have enough background to be able to set up an experiment like this. Number two, industrial engineer, more importantly, of course, I mean technical background, but more importantly, industrial engineer should be able to set up this whole thing before it is actually done and try to make some use of it. Now, we still didn't know how we are going to use this information. We still don't know. But that's the next step. Okay? How are we going to use this information? Now, of course, now intensity of heat and cooking time is going to give us what? We have to find a performance measure to evaluate the possibilities that we have here. Now, what will be a typical performance measure? Performance, what do we mean by a performance measure? Now, I have a lot of alternatives here. I want to select one of them. And so I have to make sure that I'm going to select that one with respect to some function, which I call performance measure. Now, in TOS-Kaizen example, if I were to select the TOS-Kaizen example analogous to this, what was the performance measure there? The guy actually had a certain way of doing it, and then he improved it. Total time.
The gas or the heat.
Okay, time, gas for the heat, total amount of gas that's used. Anything else?
Physical tiredness. Physical
Physical?
tiredness.
What do you mean by that?
The power of work.
The power of work. Okay, so it is a function of gas or energy that is used. So energy is probably synonymous to gas. Anything else? Yes?
Quality.
Quality. Okay. Anything else? Okay. Now, I can see that. Let me start with quality. Now, first of all, what is the assumption here? Assumption is that these are all acceptable quality. But if you are preparing this rice for a Michelin restaurant with 5 stars, the most expensive restaurant around the world, then you will definitely ask Vedat Milor, or your chef maybe, to select one option, regardless its intensity of or cost or anything, the energy that's spent, which gives the taste that he or she wants. Okay? But that's another type of an objective, which is a reasonable objective. So this is not going to be very useful then. You don't want to have the admissible set. You want to have the one with the ultimate taste. Okay? That might be an objective function. But in this case, in our setting, we are not looking for that. What we are looking for is we are looking for acceptable quality. Of course, in some circumstances, you will have quality as the objective function. Yes?
Teacher, can we say that quality and the other performance measures are different tests, and we need to set one of them as our primary?
Okay. Now, primary in this case is, now, if we make the following, you see, you have to start thinking about the type of problem. Who am I solving it for? Am I solving it for this grandiose chef who is going to create the best rice dish of the world? Okay, then quality is going to be the case. You don't care about the money or the energy spent or whatever. Or are we solving this for a caterer, for a regular caterer, who is trying to minimize what? Cost. Total cost of preparing the rice.
Or time.
Okay, time is also about money, am I right?
Yes.
Okay, because you are making some people work, and so it's about money. So maybe as a performance measure, we can take cost here. So performance measure here is going to be cost if we are solving it for a caterer. So that was the starting point of our example, caterer. We said that economic motive of a caterer. So cost is important. Now let's look at these. Time, cooking time is important because we are spending energy. We are keeping the equipment of the kitchen busy. We are keeping the pan busy, okay? And we are keeping the kitchen busy, well, that part of the kitchen busy. So time is money, actually. Gas is money, actually. Okay? Energy, in general, is money. Quality, they are all admissible. We accept that as quality. In other words, what we do is, in this case, we say that we assume that they are going to satisfy our customers. Now, of course, you can approach the problem in a different way. You can say that I want to make sure, I'm an environmentalist. I want to make sure that I spend the minimum amount of energy possible. Okay? So that might be another way of looking at things. Not in this problem, probably, but in some other problems, that might be the thing that is going to be the most important as performance criteria. So what are we up to now? As IEs, when we are setting up this problem, we have to make sure that we understand the details of the problem. What is the problem that we are trying to solve? Who is the owner of the problem? Okay? Is environmentalist owner of the problem? Is this grandiose chef owner of the problem? Or a caterer firm is owner of the problem? And then what we have to do is we have to select a performance measure that fits the original motivation of the owner of the problem, whoever that owner is. Sometimes the owners are going to be central authorities. So we are solving, let's say, a problem that is related to the citizens of a certain country, or sometimes it might be a certain organization like Greenpeace. Sometimes it can be a company which tries to maximize the profit. So the objective function might be similar problem, objective function might be different. So same problem caterer, same problem army, okay? Same problem might have different performance measures. So our role is to set up this whole problem in the beginning to make sure that we understand for whom we are solving the problem and accordingly select the performance measure. This is a technical task, actually. It is not a non-technical task. It is a technical task because depending on the objective function you select, the problem, the mathematical problem that you may come up with may be solvable or may not be solvable, may be very difficult to solve, may be very easy to solve, but you have to set up the correct problem. Now, the other engineers usually deal with less number of alternatives. Or even if they have more alternatives, they have a certain way of dealing with those alternatives, looking at the tables. In other words, to handle the selection problem among different alternatives, they have tables. Whereas in our problems, as the problem structure may still be the same, the owner of the problem may be different, we have a lot of alternatives that we may need to consider. If we don't have alternatives, then industrial engineers are not important. Any smart people can make decisions in between 3 or 4 or 10 different alternatives. Okay? You don't need to be an industrial engineer to do that. You need to be an industrial engineer if it turns out that you have a lot of alternatives and you need to apply techniques to figure out the differences between alternatives. Okay? Now, in this problem again, but here we are not even solving the problem. Actually, in IE-102, we are not after the solution of a problem. We are trying to see different ways of setting this problem up. Because in the later years, you're going to learn a lot of techniques, a lot of approaches that will solve different types of problems. But in none of the courses, except the 4th-year course, project course, you're not going to learn how to relate a certain real-life situation to the problem environment. So this course gives you an understanding of a motivation on how to do that. This is a very difficult task. It looks very simple, but this is really a very difficult task. This is the main problem of IEs in the market. Okay? They have to be able to come up with the correct problem definition. So this is actually the start of the problem definition. So now let me close that large parenthesis, but let's go back to this problem. So we selected performance measure as cost. Now, what are the cost issues that's related to this simplified version? Now, of course, as I have a specific type of rice, the cost of rice is not important because I'm already solving this for a specific type of rice. Certain pan, we are not going to include anything that's related to this. But what is changing with our decision is cost of the heat and cooking time. Because basically, I think it comes to what you said. You have a certain total time, and then you multiply it with a certain heat factor, and then there is a certain area that's obtained, not necessarily linear, but you have a cost associated with that. So there is a certain cost associated with each of the points that we have in this region. Okay? Now, is this cost linear? We don't know that. It depends. We have to ask the food engineer. We don't know that. We don't know. We usually wouldn't know the physics of the problem that we are dealing with. Unless if you are consistently working in the same sector, you start learning them. Okay? But what we know is we know how to approach these type of problems in general. That is a little bit confusing as well. Because IEs always think that I don't know what I'm going to do. I don't know which sector I'm going to work at. You can work at any sector as long as you have problems that have a number of alternatives. You have problems that can you have some people around you that will be able to identify alternatives to you, because you are not mainly responsible to do that. And the remaining part is yours. You can do a number of things actually to deal with this. So what this means is that this is sort of, there are infinite number of possibilities here, but each of them has a cost. Okay? So given this graphic, given the cost figures, then I can select the alternatives, which is going to minimize my cost. Now, calculus. This is the place where we are going to have calculus coming into picture. You have a certain set. There is a certain cost function that you define on that set. Okay? But this is a two-dimensional problem. It's not a single-dimensional problem. So there is a certain cost function. And you are trying to find the minimum of that two-dimensional function. And that's calculus. Am I right? Now, if I give you a single-dimensional problem, you can solve it much easily. If there are two dimensions, then you have to make sure that the solution that you find is optimal. There are no better solutions. It's not a local optimal, but it's a global optimal. There are a number of things that you're going to learn or you're learning in calculus courses. But basically, this is mathematics. Once you have this, this is mathematics. Now, I can make the problem more complicated. I can start putting some other equations that you have to fulfill, the solution has to fulfill. For example, I can say that this is only true if the differences in this cooking time is a certain level. I can complicate this problem, put a number of constraints and so on and so forth. Now, this general form is called mathematical programming in industrial engineering jargon. Okay? So you have an objective function where you minimize, let's say, cost. And then this is a functional form, of course. And then you have a number of mathematical functions that will relate your decision variables with each other. You might have some constraints regarding the total heat, for example. I don't know. I mean, there might be a number of things into that you might want to consider. So usually this structure is called mathematical programming. Now, we are, in the undergraduate studies, you are going to learn a simple mathematical programming set in later courses, in a number of courses, actually. But this is what we do. Now, where did we start? Again, I want to go back. We started with a video clip, okay, where we observed a certain process. Now, our human mind understands that there are different ways of doing it. Of course, you can be more qualified by reading, which we usually should do. Okay, learn about the process more. And then come up with this definition. And at the end, what we have is we have a very valuable information. Given a certain type of rice, given a certain type of pan, given a certain type of kitchen, okay, I know the cooking time and intensity of heat that will minimize my total cost. If I am doing this repetitively 200,000 times in a given month, then this is going to save me a lot of money. Okay? So this is actually partly what we do. Any questions on this? Okay. Now, I think it's time to go one step further. Okay. So now what I have is, for given type of rice, I have a cost of preparing the rice. So I am sort of now generalizing this a little bit, of course. So what I have is I have type A of rice, and I have the cost of it. Now, I know that I have selected that cost among many different alternatives by using my objective function, which is minimization of total cost. Now, I know that if I select this type of a rice, this is going to give me the best solution. Now, should I look for, if I trust in the mathematical work that I do here, in the work that I do in converting everything and so on, which we didn't see anything at all yet. Okay, we're going to see some examples of converting this type of qualitative information to mathematical representation. We're going to see some examples of that in this course, of course. So, but I know that if this is the rice that I select, this is going to be the cost of preparing that I would end up with. Any doubts in this? Of course, I can make errors. Am I right? Because basically, how did I obtain this information? I obtained this information in a controlled environment because there wasn't any other information given to me, with a food engineer, with a chef, in a given kitchen and a certain type of pan. So these are my restrictions, actually. But given those restrictions, I obtained the best possible solution. Of course, when you are working in a catering firm, the catering firm is going to have a certain kitchen and a certain set of pans which is used, which they use. So it's not that bad, actually. But how about the rice? Now, I have to do this for different types of rice as well. For each possible rice that I think it is feasible for my end use, okay, I need to do this experiment again. So I have a set of types of rices, a set of rice types that I need to work with. Now, here, if I am a very large caterer, I can even think of a rice type which is not available in the local market. Okay, I can import it from another country. I can do a number of things. But eventually, I have another problem there. So let's set up the second problem that comes after this problem. So what is the second problem? Now, the second problem is basically how am I going to select the type of rice that I should use? Yes?
Now we are, for each type of rice, we think just minimal cost?
Yes.
Okay.
Well, because that's the reasonable objective for the caterer. Now, if it was a grandiose chef, then we would look for the one that gives the solution that gives the highest quality. Okay? So we would ask somebody to select the highest quality, so that solution would be selected. Whereas now, here we select the one which has the minimum cost.
So
yes?
We can create a quality cost graph.
Well, okay, of course you can create a quality cost graph. But here, for the caterer, it is important that it is above a certain standard. And that's how we come up with this kind of a feasible region. You have to be above a certain standard. And those are defined, actually. If you look at the standards for food, there are a number of standards with respect to how much it should be cooked and so on and so forth. I think military has very good standards with respect to them. It's called military specifications, mil spec. In short, they call it mil specs. For those of you who have a parent or somebody that you know who works in the defense industry, they always talk about mil specs. They have mil specs for everything, including rice. Not only weapons and so on and so forth, but everything that they use in daily life. Okay, now let's come to the second problem. So what I will do is now I'm going to list type of rice in this axis in such a way that the cost of rice, let's say cost per kilo of rice, is at a certain level. So what I will do is I'm going to order the different types of rices that I have available in such a way that the cost of rice will be increasing. Okay? So this is my arbitrary order. So how many types of rice that I have that I'm looking for is given here. I think 4, 6, 8, and 10 types of rice. So these are my possibilities, alternatives with respect to rice types. And this is the cost of rice that I can buy in the market or whichever supplier I'm using, this is the cost that I can buy. Now, of course, for each type of rice, what do I have? I have the cost of cooking. Am I right? So now I'm going to show with X the cost of rice. And then I'm going to have another component, which is cost of cooking. And let me show it with plus. So for every type of rice, so this is one type, this is second type, this is third type, this is fourth type, and so on, I'm going to have the cost of cooking that rice. Now, of course, your general expectation is if the cost of rice is low, the cooking cost is going to be high. That's not necessarily. Of course, we don't know that, but that's not necessarily true. But what we have is let's say, something like this. So let's try to obey that rule, at least in the corners. But we may have something like this. So pluses actually show, for that type of rice, the cost of cooking. Now, what we are interested in is, of course, the total cost. So what is the total cost? For each actually type of rice, you're going to add up these two costs, and there will be a certain total cost. So how am I going to select the total cost that will minimize it? Well, the one that gives me the minimum solution is probably the solution that I will go forward. But note that there might be some types of rices where this area might be extremely small. Because you might have a very cheap rice, but you have to be very careful with how you cook it. Okay? Whereas if you have a good quality rice, the area that you have here is going to be extensive. So if it is very limited, then the cost of cooking probably would be a little bit more expensive. So this is what I would expect in general, but you can see that there are some counterexamples to that. Now, if I look at the total cost and minimize the total cost, I can select the type of rice that I want to work with. So this simple catering problem, what I did is, in a way, I justified in a certain way. I converted it to a certain mathematical problem, and I solved this problem. This problem deals with a continuous area, because we have decision variables that can be continuous, like time and intensity of heat, which are all continuous. Whereas here, we have discrete alternatives. So I have a discrete number of those, and I want to select the best among a discrete group of alternatives. Now, of course, when you have 10 of them, it's very easy to make a selection. But what happens if you have 4 billion of them? Okay? Then it becomes more difficult. So what we do is we start doing some approximations. We approximate these functions with continuous functions, and again use calculus if it is easier. Or we resort to some computer engineering techniques to make sure that we find the minimum among 4 billion values. Okay? So that's the reason why we need to make sure that we actually work with other engineering fields as well as other professionals, like not only engineering, but statisticians, so on and so forth. But who is going to be responsible for driving the whole thing? This is our education. Our education is going to make us more experienced, more comfortable with formulating, okay, this is the word, formulating, meaning that you are bringing a certain unstructured problem in a certain formal problem. That's called formulating. Okay, so you formulate the problem. And then once you formulate this part and this part, if you have this in mind, then you can see that you can select the best type of rice under the condition that your performance measure is cost. Now, if your performance measure is something else, then problem would be similar in idea, but might not be as easy to explain here. but the idea is similar. Okay. So IEs will be responsible for formulating different parts of the problem, bring together different knowledge together so that they will obtain values that they are going to use in the so-called optimization problem. Okay? So we optimize this problem if we can actually have all that information. Now, in reality, of course, for most of the problems that we are going to come up with, we won't be able to get this kind of an information. We will have some understanding of that information. So as you get more experience, you start making assumptions with respect to the type of cost that you can have. You use a lot of estimation methods, which is statistics actually, to come up with these type of functions, areas, and these values, so on. So you don't do it only with observation. Okay, you have other things that you can do. But this is basically what we do. We take a certain problem, and we bring it to a certain level that we can make a decision. Okay, questions? Okay, now, before the break, I have 2 more minutes. So let me pose you the following problem. What happens if I decide to change the pen? Now, what is the difference between pen and all the decisions that we gave up to this point?
Time may change.
Okay, we know that it is definitely going to affect this problem. Okay, and of course, then it means that it's going to affect this problem. But what is the difference between selecting type of rice and selecting type of pen? When you select rice, you use it for every quantity you use it. So you can write cost of rice here, okay? Because you know that it's going to be for a portion, let's say. Whereas, how can you write the cost of pen? You know that the pen is going to be used maybe 1,000 times, 2,000 times. So it turns out that this is also a very reasonable problem. But for this problem environment, if you come up with a different type of pen or different possibilities, you're going to have a fixed cost rather than a variable cost. This is a variable cost. Okay? This cost is variable. But if you start considering pen, which is a resource that you use many times over and over again, this is going to be a fixed cost. Now, let me go a little bit further. I want to change the kitchen, stoves and everything. That will be another fixed cost. Now, the time frame of these decisions are different. Okay? Remember, we talked about that yesterday as well. This is long term. If you change a kitchen, you are not going to change your kitchen every day. You can change the type of rice every day, but you are not going to change type of kitchen every day. Okay? Can you change your kitchen every day? No, of course. But can you change your pen every day? Probably not. If you want to make some money out of this business, you need to keep the pen for some time. So you can see that pen is not necessarily very long term, but if you change kitchen, it is going to stay for 5 years. If you change a pen, it is going to stay for 1 year. On the other hand, if you change the rice, it can change every day. So you can see that there is also a relation between different decisions with respect to how long they are going to affect you. Okay? Now, this is another serious problem, which is partially dealt with the approaches that we have. We're going to see more examples, but I just want you to understand that we have this timing issue, also a very important part in our decision-making processes. Okay, any questions? Okay, let's take a break for 10 minutes, and I'll see you after that.